description box below, we've included great resources to assist you, including links to our how-to hub. Be sure to check it out often, as we are always updating the content. We're titling this part 2 because in part 1 we created our stack of two 7750s. Well, now our 7750s are going to become our CB or control bridge for our SPX stack or SPX fabric, whatever you want to call it. To build a campus fabric, you will need to start by building the CB, which connects to one or more port extender or PE units. The CB handles traffic to and from PE ports as if these ports were local ports. The control bridge can consist of any ICX 7650, 7750, or 7850 in a standalone environment or a traditional stack environment. All units in your SPX stack must be running the same software image, and they require fast iron software of 8040 or later. One of the nice parts of SPX is that you don't need special licensing to build your fabric. It's built into the software natively. Because the 7750 and 7650s require fast iron router images to participate as a control bridge, I'd recommend running router image in all CB devices. Also, your traditional stack that behaves as your control bridge cannot contain more than 4 devices in that stack. The final caveat that I'll cover: if you're running spanning tree in your intended CB stack, once you enable the control bridge, the stack will require a reload. Let's get our SPX environment built. We are running router code. However, if you're not sure, simply perform a show version and verify. Enter config T for config mode, then enter SPX CB enable. Our system displays it is now in 802.1 BR mode or control bridge mode. We did not have spanning tree configured prior, so no reload of the CB units is necessary. Before we continue, let's take another look at our topology. We have our intended topology here, but you'll notice some of these links are designated as lags. These aren't traditional lags, they will perform as SPX lags. Notice the port designations by each link. This will help us understand which ports to configure within our SPX lags. The ports we will use as SPX lag ports are currently disabled, so let's quickly enable them. The system would notify us that the ports were disabled if we attempted to configure our SPX lags. However, this will make the process much smoother. Next, in config mode, we enter SPX CB configure. Then SPX lag and the interfaces to be included. In our case, they are ports Ethernet 1.147 and Ethernet 2.147. This is important to note. We have links ran to each of our CB units within the stack. This helps us add a little bit of redundancy and diversity in our environment. Next, we are going to designate a port extender ID for our PE devices. At first sight, this can be a bit confusing. When we configure our PE unit IDs within the control bridge, we need to include all PE units that are downstream via the link we identify. Since we have 2 PE units, we will designate both of them. Enter PE ID 1x1x47, 17, 18. 17 and 18 are the PE unit IDs we chose, but you can choose any available PE unit ID that you wish. Because Ethernet 1.147 is the first link in the SPX lag, this configuration is also applied to Ethernet 2.147 as well. We are finished in our CB. Let's perform a write memory to save the configuration. Now we need to configure our PE units. Some items to keep in mind regarding PE requirements. All 7150 models can be enabled as a PE unit. All 7250 models, with the exception of the 7250-24L, can be enabled as a PE unit. All 7450 models can be enabled as a PE unit. In a campus fabric domain, no local switching occurs on the PE ports. All data and control packet processing occurs in the control bridge. This can be handy when you're trying to troubleshoot issues. Units in a stack must be disconnected and stacking must be disabled before the unit can be enabled as a PE device. Likewise, standalone units with stacking enabled must have it disabled before it can be enabled as a PE. Our PE units are 7450s. Within our intended PE unit ID 17, we enter config mode. Then enter SPX PE-enable. Then SPX suggested-ID 17. Now we enter SPX Unit 1. This is specifying that we are creating an SPX stack that is identified by Unit 1. This device is using our default stacking ports as its default SPX ports upstream to the control bridge, so we need to remove them. Remember, we are using an SPX lag, not SPX ports. Enter no SPX-port 1x2x1, then no SPX-port 1x2x3. Now we see they are removed, but we have no SPX ports configured. We simply add our new ports to the SPX lag. Enter SPX-lag 1x2x1 space 1x2x3. Same ports, just configured as a lag. Now for our downstream SPX PE device, we also need to add those links as SPX lags. Enter SPX-lag 1x3x1 and 1x4x1. Since this PE is a provisional PE, as stated in our command prompt, we will need to perform a write mem and reload. During the reload, let's configure our other PE. It's essentially the same thing. Config T, SPX PE-enable, SPX suggested ID 18, and SPX Unit 1. Now we remove our default SPX ports and configure our SPX lag ports. Now we perform a write memory and reload. Once the reload completes, they will join the control bridge and become part of the SPX stack. We will verify this from the control bridge. Alright, reloads are complete and our SPX stack is formed. From the control bridge, let's verify the health of everything. Let's run a show SPX. This shows us a nice ASCII art design of the connections we configured. Let's take a closer look at the connections. Running a show SPX connections, once the topology builds, we can see each link in our SPX stack. Notice how it shows us that link 1 and link 2 have a number of 2 ports and they are in a lag. Now we run a show stack connection. And we see our CB links and that the CPU to CPU packets are fine between both units. This is exactly what we would expect to see in a healthy SPX stack. A little trick I'll show you is how to gain a remote connection to any of your SPX devices. Running the rconsole 17 command will drop us into the local CLI of our PE17 unit. This is really handy if we have to grab any local information or troubleshoot our SPX stack. A show flash will show us the installed software on our primary and secondary partition of each SPX device, including our boot monitor image version. We'll talk more about this in the final part of the series where we perform a UFI upgrade on the entire SPX stack. Finally, let's cover some cosmetic features which I'm a big fan of. We can assign names that make managing our SPX environment much simpler. Enter config T, then SPX CB configure, then SPX lag 1x1x47 space 2x1x47 PE-group how-to. Now we've given our SPX lag a name so we can quickly identify what the connection entails. Then we perform a show PE group how-to and it displays our topology. Now we can configure SPX Unit 17 and give it a name of how-to users. If we do a show run pipe begin SPX unit, we can see the name we just provided for our PE unit of 17. This is really quite handy when you're dealing with a very large SPX domain with a lot of PE units. That's it for SPX. We have everything built and set up. Come back for part 3 where we perform a UFI upgrade on our entire environment. Before you go, don't forget to check the description box below and access any of the great resources we've provided. Thanks for watching.